Now, I'm not a scientist and I have no credentials whatsoever. But my understanding of the Big Bang Theory, the Big Bang Theory explains how the universe expanded from a single point. The Big Bang occurred 13.7 to 14 billion years ago. All the matter, energy, and light were all compacted into an infinitely dense point. The universe then expanded tremendously. As the seconds passed, this condensed energy was spread out, and all the forces such as gravity came into existence. Around 300,000 years after the Big Bang occurred, the universe was abundant with floating particles. These particles then slowly came to each other. The most simplest elements came into existence. Most found was hydrogen with one proton and helium with two protons. The different atoms were able to form, and then these particles became more and more condensed. Soon matter was formed. The early stars were made up of very simple elements, so they had very short lifespans of only millions of years. But the nuclear fusion in the cores of these early stars slowly created heavy elements, which, when the stars died, would become part of a new star. These stars were created in small groups and attracted other stars. These stars were grouped in irregular shapes. Then the different shapes merged to form the first galaxies. Then, as more galaxies formed, they became grouped into galaxy clusters, and then these clusters were contained into superclusters. Today, scientists know about a force called dark energy. Dark energy acts like an anti-gravity and does the opposite of gravity. Dark energy is currently the cause of the expansion of the universe. The universe is expanding at an accelerating rate today. With the discovery of dark energy, many scientists now believe that the universe will continue to expand forever, and all of the matter and energy in the universe will eventually decay within 1 trillion years. Many people believe that something cannot come from nothing, and in order for something to come from nothing, it must involve divine intervention. Now, according to quantum theory, something can come from nothing. The explanation of why that happens has not yet been formed, and it happens all the time, and it can be demonstrated experimentally. Vertical particles come into existence spontaneously. They don't last, but during their brief existence they have measurable effects. But it is admittedly a bit of a stretch to compare the appearance of an electron with the mass of the universe. Still, the Big Bang Theory explains a lot of things that are otherwise unexplainable. Quoted from Stephen Hawking's book, A Brief History of Time.
The universe, as far as we know, is all there is. Physics provides no real way for us to ever look anywhere but within it. We are cocooned from any possible communication from other dimensions or alternate realities. Other dimensions may exist, and there may even be a boundary to the cosmos, but so far, we've never observed anything remotely resembling one. On very large scales, the universe is actually a pretty simple place. It has been around for a finite amount of time, roughly 13.5 billion years. It looks pretty much the same everywhere. Galaxies are almost evenly distributed across the cosmos. Everywhere we look, we see about the same number of galaxies. It is also big, very, very big, and it's getting bigger. The space-time between all 100 billion galaxies in the universe is increasing. Like a roiling, seething froth, New, empty space-time is being created as the universe ages, increasing the distances between the galaxies, pushing them apart. Since the universe is expanding, it is a natural question to ask, what is it expanding into? When we peer deep into the cosmos, we cannot see a boundary. So far, we have uncovered no evidence that a boundary exists. Space may extend to infinity, or it may not. But in Einstein's universe, things can be curved. And if things can be curved, they can be curved in on themselves, twisting and bending the shape of the universe into virtually anything imaginable. General relativity makes it possible to live in an infinite universe with no boundary at all. Because of general relativity, space-time is not a static entity. It is a dynamic and ever-changing fabric within which the locations of all galaxies are woven. Galaxies are not themselves moving very much, but they appear to move to us because of new cosmic real estate continually injected, increasing their distance from us. It is this creation of new space-time and the rate at which it is being created which determines how fast a galaxy appears to be moving away from us. So what is the universe expanding into? When new space-time is created, into what do the edges go? The answer depends on whether or not there are edges. If we live in an infinite universe, then the answer has to be nothing. Adding more fabric to infinity doesn't make more infinity. An infinite universe would have no edges that expand, and the question is meaningless. In such a universe, there would be no outside. On the other hand, if the universe is finite, with a boundary that we have not yet discovered, then the answer may be that we are expanding into something. If that is true, however, then the boundary is so far away that we cannot see it, and it can therefore never ever affect us. We have already seen photons that have been traveling since the universe was only 500 million years old. Anything much further away lies beyond our detection forever. Given that the universe is expanding, if we cannot see the boundary now, this expansion guarantees we never will. It will forevermore get further and further away, and it will always lie beyond our detection. Only 100 years ago, we had no idea there were other galaxies besides our own. It was thought that humanity and the galaxy we inhabit was an island, adrift in a universe of 100 billion stars. We now know that our universe is a vast, dynamic cauldron of activity, home to 100 billion galaxies, all racing away within a boiling ocean of space-time. While we may yet find our universe is just an island, we have yet discovered it is much larger than we ever thought.